to write a small or large number in an easier version. So in other words, if a scientist wants to say something is an organism is super duper small, they're going to have a ton of zeros involved. They need to figure out a way to write that quickly and more efficiently for other people to read it. So when you're reading like a scientific document and they're talking about a really small organism, they're going to write things in scientific notation. And you guys have probably seen it a lot when researching, but we don't use it as much in math, but it's good to know about. So, for example, a scientist has figured out that something is this large. That's a super large number that a scientist doesn't want to have to write over and over and over again. So, they have written in what we call scientific notation. Scientific notation allows you to write a number using the power of text. It's super simple. So, the first thing you have to know to be able to write in that scientific notation, this first number, the number being multiplied by the power of 10, must be greater than 1. So you have to create a number that's greater than 1. This should say and less than 10. So you have to have a number that's greater than 1 and less than 10. So basically it needs to fall between 1 and 10. Everybody good there? And then you're always using multiplication. So you're going to take that number and multiply it. And in scientific notation, you actually use the x. I'm not quite sure why, but in scientific notation, you actually use the x. And then your base is always 10, because we're working with the power of 10. We're basically getting rid of zeros. So you're always working with the power of 10. All right. And if you want to represent a super little number, like an organism that's really small, your exponent's going to be negative. Larger number exponents are positive. Okay, so let me show you how we did this one. How I do it, and you can find a rhythm that works for you. How I do it is, I decide where the decimal needs to go. So right now the decimal is down here. It's at the end of the number. I need to create a number that's greater than 1 but less than 10. So I know my decimal is going to have to move to right here. Everybody with me so far? Everybody with me? So that's where I get the first number. I get the 7.38. You have to write all the digits unless they're just zeros and you don't have to write times, and then 10, and now we have to figure out our exponent. Is that a really small number or a really large number? Large. So we know my exponent's going to be positive. So now I just have to figure out how many times I moved it. So I start here, and I need to move it to here. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So really that's just 6 to 9. So 10 to the 9. However many times you move your decimal to that place is what your exponent becomes. Does everybody understand that? Right? It's so hard. You can leave it as a dot because when you read it, it's going to be the x. All right. You guys try these 3. Just try them. Just try them. At your table. Try to write them into scientific notation. So, hopefully, let's work these 3 out together. So hopefully you moved the decimal to right here. And you got 2.1 times 10. And then you moved it 1, 2, 3, 4. But it's a really little number, so it needs to be negative. Any questions on that one? Yes, sir.
I did 10 negative 45.
Yes, but always write it in this one. That's fine, but you totally can, but scientists are going to write this one. This one, you have to move it all the way to the end to make 9. So 9 times 10, it's a little number, so I know it's going to be negative. 1, 2, 3, 4, 5, 6, 7, 8. 10 to the negative 8. All right, and the last one's a super big number, and we're going to take it from the end to here, so 8.02 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 7. And that's a positive because it's a big number. Number one mistake middle schoolers make is just count the zeros. Don't be that middle schooler because it's not going to work. Here, if you just counted the zeros, you would have said 9, and that's not right. So be careful. Any questions up to this point? All right. Go to the back for me. Now we're going to take it from scientific and write it into standard, which is super easy. So, the exponent tells you which way to move the decimal, which should make sense. So if it's a negative, you're trying to make a little number, so you're going to move it to the left. If it's a positive, you're trying to make a big number, so you're trying to get zeros on the end, you're going to move it to the right. Just in case you get confused, if a number doesn't have a decimal, it's always at the end of the number. Just in case. I think you all know that, but if you don't. Alright, so we'll do a couple of these together. So 3.21 times 10 to the 7. So, all you're doing, you're taking 3.21, and it's a positive, and you're going to move it, this tells you how many times. So you're moving it 7 times. And you're moving it 7 times to the right. So this is what I do. 1, 2, 3, 4, 5, 6, 7. And wherever I have empty ones, I just add 0. So 0, 0, 0, 0, 0. So this is really 2, 3, 4, 5. 32,100,000. Just like that. Questions on how I did that one? Questions? Alright, you guys try the next. So hopefully on 4.7 times 10 to the negative 8. Now you're making a small number, so you need to move to the left. So 1, 2, 3, 4, 5, 6, 7, 8. Add some zeros. Do not write the original decimal. That doesn't make sense. So 1, 2, 3, 4, 5, 6, 7. Hopefully you got that. Questions? No scientist is going to write this. Scientists are going to write that. That takes forever. All right. This one is pretty simple. And you're going to move it 10 times, and it's getting bigger, so to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10. Any questions on scientific notation? Any questions on scientific notation?